On this episode of the podcast, I have with me Felix Sargent. He's the Senior Engineering Manager at Truework. We're going to be talking about technical debt. Felix has a great insight into this topic. We've been talking about how debt isn't something that you can quantify, and it's actually a little bit more emotional than you think. We're going to be talking about a great analogy he used about the boulder in the garden until it's not a problem, until you want to use that space. And I think he has great background. Well, he'll go into who he is, what he's currently doing. I'm excited to have you on, Felix.
Thanks very much. It's really a pleasure to be here. Thank you for the invitation.
Absolutely. I guess just two things we start off with is understanding who Truework is, like frames a conversation, and then also just what's your responsibilities as Senior Engineering Manager?
Sure. So Truework is a company that does income and employment verification. So effectively, if you're ever going for a mortgage, you need to be able to get, the bank needs to say like, well, do you actually work there? Do you actually make enough money? Can you afford to pay off the mortgage? So we don't see a repeat of what happened in 2008. But on top of that, Truework is also seeking to create a network of verified identity so that effectively you can go out to any bank and say, here's all of my information, all of my financial information, and it's been verified by this third party. Let's do a transaction. And being a one-stop shop for us to be able to send out that information so that you have a bit more control over your identity as opposed to where it is right now with Equifax and the data leaks, etc. It puts you in control of how that information is shared. As an engineering manager, as a senior engineering manager, I oversee the API team. We're still a relatively small startup. We're Series B, possibly going into our Series C. And we have a team of around 16 engineers. So I oversee half of that. I manage all of the backend API services, as well as a lot of the front-end stuff too. And in my career, I've been both a product manager for a large part of my career, actually. I initially started doing tech stuff at Google, spent 1 year as a software engineer, and immediately became a technical product manager and worked at Rackspace doing that for about 3 years. Then did Bloomberg, did a startup called Seamless Stocks, where I was the VP of product, had a great time doing that. And then did 3 years as the director of engineering at MediaMath, an ad tech company, before I moved over to Truework.
Awesome, man. Awesome. You've had some great stops along the way. I'm excited to have you on to talk about this conversation around technical debt. And I guess just to begin the conversation, I think maybe kind of defining or understanding what your thoughts around that definition would be, because I think it means so many different things to so many different people. And I know it's going to be maybe a long answer, but I think it's important for us to understand what technical debt means in the context of how you see it.
Yeah, I mean, my hot take is that technical debt doesn't exist, or it means it hasn't been digested, right? When you're saying technical debt, that to me is a warning flag where I as a manager go, hang on a second, if you're saying it's technical debt, then what is it? What is it really? Because that means you haven't done the work to identify whether it is something that we need to do or whether it's something that you're just uncomfortable with. And generally, I break down technical debt into two major items. One is liability, right? If we don't fix this, then our requests are slow. Transactions may fail. Our customers will have a bad experience. That's not technical debt. That is something that can be directly translated into feature work. That is something that should be able to affect and manage your key performance indicators or whatever metrics that you use in order to be able to measure the performance of your application or product. And if you do that, well, it's not technical debt anymore, right? It's not debt. There's a compelling product reason for it. Generally, when product managers and engineering teams are having a conversation, whenever a product manager hears the word technical debt, they go, it's some complicated stuff and don't worry about it. There's this complicated stuff, we need to work on it. And the amount of time that it would explain for me to explain to you, lowly product manager, isn't worth it. And in a lot of ways, it's kind of patronizing. And also, it doesn't help that product manager grow, even if they are soft technologically. And that's not an uncommon thing. But it's patronizing, and it means that you haven't done the work to break down, how does this impact the customer? Or even to say, if we do this, then, this is how much more reliability we intend to have. Or even, depending on the relationship you have with your product manager, you could just say it will be more reliable. Sometimes, if reliability is a concern that customers are having right now, product manager is going to be great. That's on top. Let's do it. The second of those is code smell. It means that as a software engineer, I don't want to touch this thing with a 10-foot pole, right? And very often this conversation comes about when like through the process of making software, one engineer worked on this project and they've left the company and nobody really knows how this thing works anymore. Or it was a founder code is like very often got a lot of code smell to it where, hey, this is the core thing that our entire company runs on and we shouldn't touch it with a 10-foot pole because no one has any idea how it works or that's very fragile. And the way to tackle that is a little bit harder. In that scenario, first, you need cause to go in there, right? And oftentimes, if it's a subject of conversation, that means the product manager is saying like, hey, I want to build out this feature. And very often the product manager is saying like, and I want to do it in as least time as possible and get it out the door for our customers so that we can impress them. And so engineering teams will say like, well, we could do that, but I think we'd incur a lot of technical debt. And what they're really saying is, I have no idea how this code works. And I think it's fragile. And even more so, it doesn't meet our definition of done, right? And definition of done is one of the first things that I introduce to a team when I onboard with them, talking about, what our code smells. How do we know when code is reliable, that we have good metrics based on it, that it conforms to our standards of observability? We know its logs, we know its performance metrics, and it's linted properly. We find it readable, right? There's documentation about it if it contains, nuanced architectural elements. Well, if that's missing, then, to track into it can be very complicated. And very often it can encourage the engineering team to say like, well, if you really want it, I suppose we could hack our way around it rather than fixing the thing at its core. That's where it gets really complicated. And this is where, as an engineering manager, I feel like I step in and say, well, okay, let's have a conversation about the hacks that we can do to make it work. And then how much work it would be for us to do it the right way so that it conforms to our standards, that we're bringing it up to date, that we are, not letting the code base as a whole down.
Understanding the liability in the code component, I think that's actually key. I think talking about the code smell, I guess what we're really maybe talking about, and it's something I'm going to ask you because I've really never understood it, is, measure twice, cut once has always been, most people's, in theory, goal in life so they don't have to repeat whatever they're doing. And I guess when we're looking like engineering, if we take the traditional sense of, let's say actually building stuff, bridges, rockets, they tend to be able to reverse engineer as much as that's science. When it comes to software, a lot of the stuff, every time every company does something, it's brand new. No one's done it. So you can't, use that historical reference point to reverse engineer. Now we know how to build a bridge. For the most part, bridges don't fall down. And it's very expensive to fix the problem because you can't really refactor a bridge once it's up. I guess when you look at, we're talking about the liability side of it first, and you're talking about, if we don't fix this, what happens? There are obviously trade-offs to be made. You're trying to get product out. When you're writing code, potentially have you trimmed a little bit of what you should to make sure it's done. Are there acceptable use cases to absorbing some of that liability, especially maybe early on in a startup, right? As a startup gets more mature, that becomes more expensive in terms of the ramifications.
Yeah, absolutely. And, that's a really big part of scope, I think, is actually the better thing. So the most important thing here is to set your standards. And as engineers, I believe that we should define our definition of done. And that refers to tests, observability, documentation, making sure that we can go back to this code later and work on it and have an architecture that we can believe in, as opposed to a hack or something where, we got it working, but we don't know for how long, right? When we talk about hacks, that's when people start talking about, technical debt very often. The hard part of the conversation about technical debt is that once you start allowing hacks in your code base, then you stop having an honest conversation with your product managers about reliability and about, the foundation of what you're trying to do. Yes, there are always business scenarios where you're like, look, we just got to push this out the door and maybe it's not perfect, but we'll get back to it, right? The question about when we get back to it is very reasonable. The hard part is like, if you're doing a hack and that's the foundation of the work that you're doing, and then you're building on top of that hack consistently, and you didn't define interfaces or ways that you can kind of encapsulate that hack, that's when, you suffer in terms of reliability and in terms of metrics and in terms of your ability to further develop your platform. But still, I would argue that like when you're making the case to product about how long will this take, which is always in the engineering domain, you should factor in the costs of refactoring that code into that estimate to do it the right way and to bring it up to your standards. Because at the point at which you're not doing that, they don't exist. And obviously these things are always luxuries where, when you're trying to get a business off the ground, I think the important thing is also to have a very open and honest conversation about hey, if we do this the quick and dirty way, our velocity will slow down in the long run, right? And product managers care about that stuff. And they can understand when you say things like that. But you always need to be able to put it in terms that the product manager will understand, either customer impact or future velocity.
Let me ask you this, because I think what you said there is very interesting about a hack. And I guess there may be two ways to look at that. One, and I'll use an example of my own life because I think this is the best way I can maybe refer to this, is my wife asked me to fix something in the house. Typically, I don't have enough information or knowledge to do it. I'll go on YouTube, I'll figure it out. And in the end, I'll probably do a 60% job. And I said it's done until something happens and it kind of exposes the fact it wasn't. Then I call the expert. And I guess a lot of times when we're talking about the hack, it might be a case where the team doesn't know how to solve the problem. It's a technical problem they just haven't seen. No one has the capability. Obviously, they're trying to get through that by putting something in place, the hack. Sometimes it is punting, going, hey, listen, we just don't have the time. This needs to get out for business decision. We'll come back to it. And obviously, that's a dangerous thing because there's so much work piling up. Going back is hard. But when you look at that, the balance of the hack is there because the team doesn't have maybe some of the understanding or the capabilities to solve a problem that they haven't come across, and versus, punting because there is the business driver. How often does technical debt fall into one or two of those categories? I mean, there's probably multiple, but how many of those two categories do you see?
I mean, I agree with your synopsis, and I think the analogy is very good. But at the same time, there are things you will do, and then there are things you will no, I'm not, like plumbing, right? Mm-hmm. Don't do your own plumbing, right? You can do your own electrical work that,
Debatable.
It depends on how comfortable you are. But when you're doing your own plumbing, things can go very wrong very quickly. So for example, I'm wondering how real to get on this analogy. I'm going through and improving something for my nonprofit, the Center for Election Science. And we have a little website where you can vote on things because we talk about voting reform and how different voting methods work. And I went into the server that runs this platform, and I'm like, where's the database? Oh my God, this is running in SQLite in production. This is literally, the database is just on disk and it's not attached to anything. And I mean, I suppose that it's been working for years, but it's not good practice, right? And so the question of if for whatever reason that server just went, right? Oh, well, okay, good luck, right? No redundancy there. So there's always the question of if we change something, will we make it worse? Right? And that's another question of liability, right? If it's working fine right now, do we want to touch it? Do we have to touch it? Is touching it worth the risk? Do we have the skills to go and make this change? What liability do we have? What structures can we put in place in order to be able to maybe do a migration year? And, do we have the scope of work necessary? Do we have the capabilities in order for us to be able to do that? Things are very hard as a startup for you to be able to make those decisions. It really depends on, how many senior engineers do you have? How technical is your CTO? Or, do you have the air cover to be able to make things like this? What kind of security and privacy implications do you have? Are you meeting your, SOC 2 standards? Do you have SOC 2, right? And you need to think through all of these things in order for you to be able to take on something that people are necessarily worried about. The other thing, though, is that you get into a bit of a little bit you need to make sure that you have a good team that knows their strengths and then knows their weaknesses. That's one of the reasons, let's say, your wife asked you to put out a few shelves or something. You can probably get it done. You should probably have a conversation about what her standards are. Should it be painted? It's implied that, it should be level. Mm-hmm. How much time are you going to take on it? If you're going to take the whole weekend, well, that's probably not going to be a trade-off that they would be interested in. Mm-hmm. One of the things that we always do when we're doing our home renovation projects, I say, is okay, I got a quote from someone and, it's going to be $1,000 for us to get these shelves installed, which sounds ridiculously expensive until you feel okay, well, how much do we earn, right? Like, what's the cost of our time? How much would I do it? And how good would it be if we did it? And then, factor in your labor and your materials. And sometimes it's just worth it to pay someone because it'll come out the same way, either way, and it'll be done better. A lot of that kind of conversation goes into build versus buy, right?
Mm-hmm.
So, for example, user management systems. Everyone needs to build or has some kind of like user management. I can't think of a real startup that does not have some kind of like account management processes. And then you need to do OAuth, you need to do two-factor, do you want to do WebAuthn? You want to do magic links, right? How do you make sure you secure those passwords? PII data, right? All of that stuff is built into your user profiles. That's a great thing to outsource. There's tons of great companies out there. Auth0, Stitch, Magic.link are like the kind of ones on the top of my list. Okta's kind of Okta bought Auth0, so there you go. That solves that. But when you have big questions about technical debt, always great to just be like, let's look if we can actually outsource this, which would be the equivalent of calling a plumber. Because now you can focus on your core platform or your core product. And very often, if things are so squirrely that your engineering team is going to be worried about diving into something, diving into something where they don't have a product manager who's able to say like, well, here's all the features that the user profile service should have, right? Great solution is to outsource it as well.
I guess that definitely build versus buy, and I guess there's a definite component there of you mentioned code smell and kind of going back to technical limitation. Why the piece of code that was potentially not optimally written was written, because obviously as you start going further down the roadmap, and if you've not made a point of coming back to addressing whatever that was, it's going to be harder to remember if you don't have it properly documented as to what decisions were made at the time to come back and address it. And like you mentioned, somebody leaves the company, the founder wrote the code, who's going to go back and autopsy that and do a postmortem to understand the impact? But I guess it's the upfront decision that really causes the code smell potentially down the road.
Well, I think you actually get to another point that I think is super important, which is, why are you digging, right? Like, look, there will always be terrible bits of your code. There will always be parts of your infrastructure that you're not proud of. Then you're asking yourself a very philosophical question, which is not like your definition of done, because there will be things that don't meet the definition of done. And, it's not a question of code smell or even sometimes reliability, because, it's chugging along fine. And the product manager isn't necessarily like trying to do something, but I should probably get this system off of Python 2.7, right? Python 2.7, not something you should be using these days. But it's only going to break if you try to change something. And so this is where I often talk to people, often engineers, lead engineers who are very kind of like keen on doing the right thing and making sure that everything's at the standard. Is one, is this the most important thing you should be doing? And two, is this is very meta, but like the Buddhist definition of suffering, right? Like suffering is the difference between what things are and what you want things to be, right? And technical debt, when people talk about this platform has so much technical debt, well, what do you want it to be doing? How differently do you want it to perform? If you're just saying like, it's just got lots of technical debt, I feel like it's not working. It's written in Perl. We can't use Perl these days, right? Like, well, if it's doing its job and it's staying fine, you don't need to add any features into it. Is it really technical debt? Do you need to dive into it? And do you need to change anything there?
And I guess that's a good question. I think you talked about, liability, you talked about reliability, you talked about the relationship with product, right? And obviously, if reliability is an issue, they're hearing that as an issue from the customer, then that's when, you were talking about why are you digging into the code? If it's not causing something of a detriment to customer, internal processes, whatever, do you really need to go back? I guess at this point, it does become philosophical because, the ROI to fix that when it's not a problem. I guess, the old adage of if it's not broken, don't fix it comes into play. And I guess the ramification of that is when it is broken, that's when you wish you had addressed it, but you won't know it until it happens.
Well, I mean, that's where instrumentation can take place and observability, but very often those are tangential from fixing the thing that attracted you to it in the first place, right? You want to say like, does this break? Not necessarily, this is broken because it's out of date or, And so like putting in the instrumentation there can be very valuable.
Awesome, man. No, I think that's been a fantastic discussion, and you have great insights into this. If somebody does want to reach out to you and kind of pick your brain on anything you talked about, what's a good way of getting hold of you?
So my email address is felix@truework.com, or you can go to my personal email, which is felix.sargent, SARGENT @gmail.com. And felixsargent.com is a website that I manage. LinkedIn, anything like that is absolutely fine. And I'd really encourage people to check out the Center for Election Science, a nonprofit. We're bringing election reform to Seattle right now, where there's a campaign going on. They're gathering signatures, trying to bring approval voting to Seattle. So if you're in the Seattle area, go check it out so that people with the most support can win, as opposed to current system where people split their votes and the wrong person wins.
Absolutely. We'll include some of those links. It sounds like a great cause. We'll put that link in the show notes as well. Again, thanks for being on. It's been great having you. But that's it for this episode. We'll be back again, another guest, another topic, another day. Until then, I always ask for two things. One, if you like the podcast, share it. It's how this podcast has been growing, and it's been amazing. So thank you for that. And the other is, if you do want me to talk to a guest about a specific topic, let me know what that is, and I'll do my best to find someone to address it. Until then, goodbye.